Welcome back, everybody, and a very good afternoon. I hope we all had a very great networking break. So now we begin the next session. Well, ladies and gentlemen, the next topic of discussion is going to be key management preventing cyber attacks. And we have a next speaker, Mr. Prasun Srivastava, Senior Solution Architect, India and SAARC region, Cloud Protecting and Licensing Thales. Ladies and gentlemen, Mr. Prasun has been involved in many turnkey projects in the BFSI and government segment in India, such as UPI, RTGS, eSign, Aadhaar, and many more. With a very great experience in designing and architecting solutions, ladies and gentlemen, I take the opportunity to welcome our next speaker, Mr. Prasun Srivastava.
Thank you, Praveen. Hi, my name is Prasun, and I would like to share a short presentation with you today to detail out how Thales, the organization that I represent, plays a role in ensuring data security and addresses cybersecurity related risks in the utilities sector. So without further ado, let me share my presentation and I would be grateful if you could let me know if my slide deck is viewable.
Yes, we can see the presentation. Thank you.
Okay, great. Thank you very much. And is it in full screen mode?
Yes.
Wonderful. Thank you. Great. So let me first address the topic that I would be speaking on today. So we would be addressing largely the concern related to ransomware and malware, which has essentially affected the power sector largely in recent times and has caused major headaches in most countries around the world. As we all know, the power sector really comes under national critical infrastructure, and any disruption or any unknown intrusions into this infrastructure is usually considered an act of war. Serious considerations are taken if such an act happens. So we have seen some of these incidents happen in the US. We have seen some of these incidents happen not far from home as well. And this we see as an emerging vulnerability to the point that United States government, right from their president's desk, had to issue a very specific directive addressing this major concern for this particular sector. So there's one aspect of it that we might all be aware. Some of the baseline security practices that we all do in order to ensure adequate fallback measures are there to tackle such kind of an incident. For example, we depend on cybersecurity training. We deploy, gateway measures like scanning, DNS monitoring, etc., to ensure that proper sources are only allowed access, proper external sources are only allowed access, and all such access is probably scanned for known vulnerabilities, etc. We all do this, and apart from that, we also follow backup recovery, proper backup recovery process, and SOPs are in place that allow organizations to quickly, I would not say quickly, but allows organizations to make recovery a possibility if such a scenario happens. However, in today's world, we are seeing a lot of these baseline security practices becoming irrelevant because most of these vulnerabilities have no previously known signatures. and if they have, they are able to obfuscate it, modify it so that they are not detected by these gateway systems that we deploy. Known sources are no longer secure. So if we restrict ourselves to only known sources of IPs whom we allow access, it still doesn't work. Somehow these vulnerabilities are able to hop, jump, and skip and infect the entire chain from a particular source. And security awareness training, well, it has helped in the sense that it has really educated us. But when it comes to enabling us with active tools to counter such a threat in real time, it really doesn't do that. So all of these baseline security practices, even backup and recovery, are also not feasible in certain cases. We have seen that the recovery process has taken such a long time that by the time that recovery has happened, the service and the production has taken a huge hit. So the recovery process itself was deemed unsuitable because of something like that happening. So how does we as an organization, Thales, help deal with this situation, and why is this situation even critical to the power utility sector, power sector? In utility solutions like MDMS, meter data management systems, and other core systems that collect a lot of data associated with supply in general. All these are basically, in traditional sense, huge data repositories. So they are databases. They consist of application layer gateways. They consist of interfaces that that allow multiple applications to interact with them. So this is in essence what they consist of. So all these areas, applications, application processes, and data repositories, big data repositories like databases and structured, unstructured, all these are really the things that ransomware or something like this chooses to attack. This is exactly what their targets are. So that is why having this sort of security in place for the power utility sector is very important. And along with that, trusted key management, which I would also speak about in a short bit. So some of the things that we are able to achieve with our solution, very critical, and helps in a scenario where an unknown application process, an illegitimate application process, somehow embeds itself in your infrastructure and tries to spread and access these critical resources. The way we help in such a scenario is by enabling security at the core, at the data itself. So we allow organizations to whitelist known applications and processes. So you might have, let's say, 5 different applications or 6 different application processes that are supposed to access the databases, that are supposed to access the application gateways and the configuration files and so on and so forth, whereas all other applications are not expected to access them in any which way. So the what we provide in this scenario is the ability to whitelist those known applications by their signature in a very efficient manner, where the solution is capable of learning learning the signatures of the application processes themselves and whitelisting them themselves without an administrator to go through all the hassle of detecting what these processes are and ABCD. We are able to provide such a solution that allows a security enforcer to learn the regular access that is expected within an ecosystem and whitelist them only, and hence stopping all other kinds of access completely. And this is what ensures that this kind of ransomware, etc., or malware or spurious processes are not able to access your critical data, and hence not causing a disruption within your ecosystem. The same solution is also able to provide prevention for privileged access as well. So there are cases where the way in which these type of application processes try to attack is first by assuming or escalating their identities to some privileged level from which they can easily run their or execute on their payloads. So that is exactly what we are able to detect as well. So in our solution we are able to detect if some application process has escalated its access to something else than what it was before, and we are able to report on that. So that those are most important two critical abilities that our solution has, that helps organizations take adequate control if such a situation happens. That being said, it is not just this layer of protection that Thales, our organization, provides a solution for. If you look at the slide that I am presenting in front of you, we have a variety of solutions that we can provide to the utilities market. And we provide end-to-end. We have solutions in place that can contribute to the value chain, right from providing secure communication modules to the utility meters themselves, as well as to providing an overarching security to the communications that happens between these endpoint IoT devices to the backend, as well as protecting the data at its core in the way that I explained. One other important aspect that Thales also plays a major role in is protecting the machine level identities that are used by these endpoint IoT meters to communicate or authenticate themselves to their backend. So as we all know, there is lots of solutions, lots of very good solutions in place that allow organizations to properly manage and control user level identities. But when it comes to machine communication or machine level identities that are used to enable the same kind of interaction from one machine to another machine, we usually fall short. We are not able to find really very good solutions in that space, because that is largely an untouched area, and cybersecurity experts are still trying to formulate policies, laws, and guidelines around that. In case of utility meters, we have very often seen the most common scenario is that usually a single identity is used uniquely, or rather used uniformly by all the meters. And if that identity or that machine level identity somehow gets compromised, then it just gives an attacker an entry point into your ecosystem, which you would not like to have. So all of this is something that we provide from an organization perspective. So let me detail out a little bit and probably explain a little bit on how the solution around ransomware protection that I explained earlier works and what it does. So you can imagine a scenario where there is a dedicated database where a dedicated application is using a certain process exposed by the database to access data from it. Now, in this scenario, I would probably know the legitimate process using which this data repository is going to be accessed by the application, and that process, I might not know the details of it, but I would be able to find out by using a solution that is capable of telling me that runs a behavioral scan or a learning of some sort that allows it to report back to you what are the legitimate processes that are accessing this database on a day-to-day basis. So if you get something like that, and you are able to associate unique signatures associated with that process set, then what you are able to do is you are able to enforce very granular controls, access controls associated with that data. For example, if I know there is an application which is mostly a reporting application that is only going to read data from my repository and not going to write any new data to it, I can only give such access to certain process, thus limiting its access capability on the data repository and ensuring that there is no open vulnerability even in legitimate processes that somebody can take advantage of. So all of these, this is achieved using very granular access control policies, which are easily enforceable through a single pane of glass in our solution. And our solution is capable of going through the learning process and creating unique signatures associated with these processes, so that you can enforce these sort of policies in place. So that's one of the things that we provide in our solution. And of course, the same thing applies to users as well. So whatever you can do for processes, you can obviously do for users as well. You can prevent privileged users from accessing repositories which they are not supposed to read or which they are not supposed to write onto. All of that can be enforced using the same solution. Now, addressing the use case around machine identity that I spoke about, the typical way in which these IoT deployments or utility meter deployments are done is, as I said, there is usually a single identity which is probably shared by the manufacturer themselves, which is uniquely used, or rather uniformly used all across the board for allowing access or authenticating to backend systems. So this is a huge vulnerability from our perspective. And in fact, this has been the root cause of certain very well-known attacks that has happened and exploited by well-known bots which launch such attacks in the IoT space. If you guys would have probably heard of a bot named Mirai that actually pulled down all the core domains, large core domains like Google, etc., in the US for a long duration at a given date, just by synchronizing among themselves a DDoS attack to happen on these core domains. And it was flooded with so many DDoS attacks that actually the firewalls or the components, the security components that were in place to prevent such DDoS attacks, they became one of the core vulnerabilities of the ecosystem because they were the ones that were stopping access from the service completely. And where did these bots run from? These bots ran from security cameras, access points that were deployed all across the country. And how did this bot even get deployed within these security cameras? Because lo and behold, all of these security cameras were using credentials, identities that were issued by the manufacturer by default. And the malware creators knew, and such identity was compromised duly in time, and this attack was launched. So it's a very similar use case here because this falls under national critical infrastructure, and basically all the IoT nodes are processing nodes. We have to understand that they have the capability, they are like endpoints, they have the capability to launch new communication, have the capability to interact with services, they have the capability to communicate with the stuff that is online. So all of this becomes very critical, and in such a scenario all of these IoT endpoints should have, like in we do with our laptops or other endpoints of this nature, we issue them unique identities. We do not reuse the same identity over and over again for each and every one of our endpoints. So in a very similar nature, the same thing needs to be enforced on these IoT endpoints from our perspective, from a cybersecurity posture perspective. In fact, if we go through some of the guidelines and mandates that I'm going to discuss about a little bit later, you would probably see that already taken care of from an India perspective. But when it comes to enforcement and actual audit, that has not happened yet. But once it does, I think we will be able to realize these gaps in a far more detailed manner. So we provide a solution here that addresses this concern and allows you to securely provision unique identities to all these IoT endpoints, utility meters, etc. And it's completely agnostic and very flexible, from completely agnostic of the head-end system that you are using or the head-end application you are using. It's completely agnostic of all of that. So that is exactly what we provide in our solution. So just to give you an overview of the security architecture that Thales provides, apart from the other components that I spoke about, if we restrict ourselves solely to security providers within the given infrastructure, we have a major role in providing the backbone of all the security components that we spoke about, where we are able to provide a platform that allows you to securely apply the controls that I spoke about. We are able to provide encryption, unique encryption solutions, which is very different from IPsec or TLS, SSL solutions that people tend to use, which actually is a major roadblock when it comes to implementing these kind of distributed infrastructure. It actually slows the entire process down to the extent that actual data collection messages that are generating from these IoT components become huge. It has a huge overhead because of these kind of security. So we are able to provide a very good, very low latency, almost to the point of 0.0001% latency, very low overhead in the terms of a few bytes of data that is added on top of your normal data packet, that allows this communication channel to be completely secure without any vulnerabilities, and it is even the security is up to a level of being quantum resistant. So if needed, even with the new attacks which are coming in the foray, which is supposed to be a huge threat with the advent of quantum computers, we are able to address all those threats using our communication encryption solution. So this is what we do. Um, just to reiterate or summarize some of the aspects that I've already spoke about, some of the benefits that we provide and which are globally recognized are related to securing the machine identities and the keys which are used to protect this infrastructure. We are able to ensure that only legitimate applications or legitimate software is allowed access within the ecosystem. We are able to prevent any sort of misconfiguration within the application causing an issue to the infrastructure, because human error is very frequent, and sometimes when an application is deployed, a minor misconfiguration can lead to a huge vulnerability, or maybe delayed patching may lead to a huge vulnerability. We are able to prevent all such things from happening using our solution. And of course, cryptographic storage that I spoke about. Coming back to some of the rules and laws of the land, from our perspective, I think the Ministry of Power has been very active, and the regulator has played a very good role in taking the right step at the right time. Very recently, there has been a directive from Ministry of Power, so addressing these same cybersecurity related concerns, and there are certain standards which are mentioned from such a perspective within the document that needs to be followed. Apart from other stuff which is also mentioned, like appointment of a CISO, having proper risk assessment done on in the utilities infrastructure and all of that. Apart from that, there are certain well-known global standards which is actually followed by our solution, which is in place. And in fact, earlier also in 2016, there was I would say, a paper written in India that addressed some of these, some of the points that I spoke about, like securing the algorithm for encryption, decryption, ensuring that the keys are segregated and kept separate from application owners or data asset owners, so that keys are not compromised in any which way. So if we look at all of these guidelines, you would probably see that securing the communication channel and ensuring that security is enabled at multiple layers, like not just at the network layer, not just at the database layer, but at every layers there is adequate security in place, and proper key management is done to ensure that this security is effective and not compromised in any which way. All of these are general messages that are repeated over and over again all across the standards that I've spoken about. Apart from that, Thales has participated largely in this sector globally. It's a well-known, we are a well-known solution provider. Our solutions cater to many global standards which have been issued from time to time, like NIST, federal NIST standards, which talk about smart grid cybersecurity, advanced metering infrastructure, AMI security task force standards. Our solutions are fall very much the under the purview of such standard bodies, and basically align with whatever directives they mention, and in terms of features, in terms of capabilities. I just wanted to say that the last link that I have is from a national strategy for trusted identities in cyberspace. It is a very good read, which has come out of the White House and in currently under enforcement at the policy step in US. It talks about some of the things that I mentioned today, having trusted applications, ensuring that those applications are trusted based on digital identities associated with them and not just based on anything else. So, like I talked about, having a digital signature associated with a trusted group of applications and then trusting them with access into your infrastructure is what it essentially talks about. And ensure, of course, from a user level, which user is having what type of access. All of those are very critical. And lastly, of course, encryption is, it's a pretty well-known concept. And encryption as a technology has proven its worth uh, in terms of preventing or rather ensuring confidentiality of information, sovereignty of information, which is maybe shared or deployed over the cloud or is present on premise. So all of these are solutions that Thales is able to provide and thus enable organizations, especially utility sector organizations with. That being said, thank you very much for your time, valuable time, and do let me know if there is any questions.
Thank you so much, we have few questions for you, so I request you to please go through your chat box.
Okay, or would you want to maybe read out some of those questions so that I'm able to address them?
It's been sent to you actually, so.
Okay. Okay, so how vital is OT or IT integration to the prospect of cybersecurity? Okay, so that's actually quite an interesting question. Yes, when we talk about NB-IoT or NB-IT having a large role to play, definitely it is very important. And when you say what is the need for it, so yes, absolutely, it needs to be very closely integrated. So when we talk about security by design, we always say that security cannot be implemented as an afterthought, right? So while solution providers like us would probably try to come up with solutions that would be agnostic to agnostic to such components, but to be very honest, it is very very important for these components or subcomponents integration with our security solutions so that they are enforced right from I would say right from base itself. That being said, we all know that you know uh, the, the, this is still a developing field, and NB-IT or NB-IoT, if you talk about, is not really there when it comes to adoption of cybersecurity within their uh, purview of applications or infrastructure that they provide. So hence, we as vendors try to address such issues by creating solutions which are agnostic to them and still can be very relevant and implemented successfully in these scenarios. How are users, devices, and assets that connect to the grid authenticated to ensure only authorized access is allowed? Okay, so there are multiple ways this happens. Uh, Typically, device manufacturers embed some unique identities within within these devices. Now, such identities are usually of like a PKI certificate and a key. So it somehow relates to some in-house PKI that they might be running at their end. But when they issue these identities, I think one of the major mistakes that they do, or maybe it is for their own benefit, that they give they issue same identities to same type of devices. So at the end of the day, you lack the capability. If you continue to use their own PKI identities, you lack the ability to uniquely identify your endpoints. You can't do that because they all have the same identity. So the most effective way that this is currently done is by deploying an in-house PKI ecosystem that is capable of issuing unique identities to users, to devices, and to other assets. And of course, ensuring that the device vendor themselves are capable of accepting external identities, or has a way of embedding external identities within those devices. And once that is achieved, using those specific identities that has been issued by your own infrastructure or your own PKI environment, you can choose to allow or deny access. That being said, um, uh, PKI is not the only way. As I said, we the way that we identify applications and processes using unique signatures can also be implemented for machines as well. And there are solutions. We have partners that have such kind of solutions that can uniquely identify machines and assign non-PKI identities, which look a lot like unique device signatures. And those can also be used as well as PKI. So, do restoration plans reflect smart grid assets based on their priority designation? Okay, so I guess the question is uh, talking about a recovery plan that I spoke about previously,
Yes.
where yeah. So I guess the question is, if we are talking about digital assets associated with a national smart grid, maybe, then is it usually done on on some priority? I mean, or is there like a priority designation associated with processes, etc., that can be that should be recovered first rather than later? So yes, I mean that is part of any recovery process, right? I mean, at the end of the day, when you are running a critical infrastructure, and you would be running a variety of processes internally. Some of them might be core, and some of them might be peripheral processes. Of course, the core processes is what is most critical, and the core processes is what you would you would prioritize to recover first. But that being said, if we are talking about a critical infrastructure like smart grid, and recovery process itself, it is very important to understand how much time is would be needed in order to recover the core processes or these prioritized processes. If that time is unacceptable, I mean, it is in some cases. We have seen for very critical digital services or digital systems and IT, it is absolutely not possible to go through a certain time duration for the recovery process itself. And it is in those scenarios that we recommend that you take adequate measures and ensure a recovery will always be there. But how to avoid a scenario where you might need to recover is what what I wanted to stress upon, and ensure that there are many checks and balances in multiple layers in place, so that such a scenario doesn't happen. But that being said, yes, I mean, that is how typically recovery is done.
Thank you so much. We
Sure.
have a few more questions coming in, but I think we are running out of time. So we're going to send you across on your email.
Sure.
Thank you so much to
Okay.
make it so interactive. Thank you.
Okay. Thank you. Take care. Bye.